Okay, so the first part of it is just making sure everyone is comfortable with the difference between congruent and similar. In congruent, no matter which way triangles are turned, every part of them are exactly the same. So I put a little line here. The matching side over here is this one. So this line means that the lengths are exactly the same. And I'm going to pick, I guess, let's see, when I flip this around, let's say this one, and this one is flipped like here. So this is the corresponding, well, not flipped, it's been rotated to here. So these two have the same measure. And then these have the same length as well. So length is a better term, used measure mainly for the angles. Well, the side lengths are all the same, matching up like that, and the same thing is true for the angles. So if I take this angle here and put one arc, a single arc is telling me that these two are the same. I don't need to know the amount, but it is mathematically the way that we tell each other that whatever measure this is, this has the same measure. Well, this one doesn't have the same measure, and so I'm going to put two arcs on it, and the matching one for that is here. Now, it's easy once you have something like the sides on there, because I know that this arc is the arc in between side 1 and side 2. Side 1 and side 2, so it's that arc. And then this smaller angle is 3 arcs. And that tells us that these angles are the same measure, but they're different from the other ones. So when you're talking congruent, you're talking the lengths of the sides are all the same, and the angle measures are the same. In similar, the angle measures are the same, but not the lengths, as this one clearly shows. I made that one very clear. So what we're going to show here is, notice, let's go, well, I guess we'll keep it similar to that. That and that, those angle measures are the same. And then these angle measures are the same. And then, of course, the third ones too. 1, 2, 3. So you can have angle measures the same, even though this is a lot smaller, that one's a lot larger. Okay? Now, for them to be similar, though, I'm going to write here that the angle measures are congruent. That's the word we use in geometry for being equal. So we just have to get used to that one. And we use that symbol where it's an equal sign with a little line over it. That's congruent. It really means the same thing as equal. It's just that the math world has decided that when we're talking figures, we use congruent instead of equal. So we'll use congruent and go along with it for it. The sides, I should put sides, side lengths are in proportion. So they're not equal to each other, but they're in proportion. Sort of like if this was amount 1, this would be 2. It would be double. And then whatever amount this one would be double for that. And whatever amount this is would be double for that. And we're going to be looking at that for some of these over here. Okay? So we're going to be doing that in the bottom of this paper. Okay. So let's take a look at this. There are 3 particular postulates or theorems that tell you whether or not they are actually similar. Now, you've done congruent before. Similar is not necessarily new, but you haven't dealt with and done as much with similar as you have with congruent. So the rest of this stuff that we're doing is on similar triangles. And there are 3 theorems, angle, angle, side, 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 angle, side, that prove that 2 triangles are similar. And actually, many times you can have like 2 different ways to prove it. If you have enough information, you might be able to do an angle proof, or a side proof, side angle side, whichever it is. So oftentimes you do it 2 ways. Well, let's focus on this one first. If you see, if there's enough information to show that 2 pairs of angles are congruent, then the triangles are similar. That's all you need, just 2 pairs of angles congruent. You don't need 3, because if 2 of them are congruent, that forces the 3rd pair to be congruent. There's no choice, they have to be. So all you have to do is find 2. So in this case, I'm going to number these A, B, C, D, E, F. And you know what, I'm going to do that for all of them. So let's just take a moment and put A, B, C, D, E, F, A, B, C, D, E, F. Okay, so let's go back up here to this one. So I am going to say here, I'm going to put this and I'm going to put this, and then I'm going to put this, and I'm going to put this. Nothing more right now. Single arcs for A and D and double arcs for B and E. Nothing more. That's enough. If you see this, you can say, because I have angle A is congruent to angle D, angle B is congruent to angle E. This is given information. This is given to you. Because that's given to you, you can now say that the angle theorem, or postulate, I don't remember which one it is. Postulates have a proof to them, and theorems are given based on given information. But if I have two of them, I can say, aha, this means that because of the angle theorem, these two are similar triangles. Now's where I'm going to get really particular. You have to write a similarity statement exactly the way I want it, so you're going to have to memorize this. What you're going to do is you're going to say triangle A, B, C is similar to, and that's the similar sign, symbol, triangle D, E, F by A, A. Now let me explain the parts of this and what I'm particularly particular about. Okay? Most people don't have any problem with using the similar sign, but many people forget to write the reason why. So you have to write by one of these three things. And in this case, the proof for this one is AA. There's enough information to say AA. So you have to actually write AA. You have to write by AA. I expect to actually see that. But here's the big thing that people have the biggest trouble with is I put A, B, C, I put it in this order. A matches D, and B matches E, and C matches F. So D, E, F, the order of this one has to match the order of the first one. So if this was completely in isolation, this is triangle DEF. If you said triangle EDF or FDE, perfectly fine. They're all the same. But they're not the same in comparison to this one. If I choose to say EBC, I must write DEF. If I said triangle ABC is similar to triangle FDE, that would be wrong, because they're not in order matching each other. FDE is a way of naming this triangle, but not if you're matching it to this one. You have to keep it in the same order. If I had decided to say BCA, if I said BCA, perfectly fine. But then I'd have to write EFD so that each one matched each other. So A matches D, B matches E, C matches F. If I made it BCA, then I'd have to have B matching E first, C matching F, and then the D and the A would be last. Get that right. I will take off on the test if you don't have them in order. I will look for that. I will particularly look for it. If you have a problem like this, and you decide, oh, well, I don't feel like doing ABC and I do CBA, nothing wrong with that. You can do CBA, but you better have the other three matching too, because I will look for that. I'll be ready to look for it and see, oh, this person switched the order of the letters. Did they also match on the other one? Yes, they did. Good, they get credit. Okay, they didn't? Oh, well, so I will watch for it because I'm really particular about it. And you'll find that as you go further, certain things, teachers, professors in college, some things they don't really care which way you do it. Some things they really do care how you do it. And this one's really important. You have to match up those. So I belabor it and I make a big deal of it, mainly because every time I do a test on it, there are people who don't do it, and then they're like, oh, I didn't know I had to do it. You were in class, you listened, I actually came to class this time. I'm actually here teaching it this time, unlike the last few weeks, so now you know that. So let's make sure you get that this time. Okay, now the next one, we're going to do the same kind of thing, but I have to give you enough information. Right now there's no information. So if I do this, I have a couple of things to do. I can't just use the little lines to say they're equal because they're clearly not. It's not a congruency issue, it's a similar thing. So what I would do here, I'm not going to tell you anything about the angles, we're going to look at the sides. So let's put these numbers here. AB is going to be 15 units, BC is 12 units, AC is 18 units. So 15, 12, and 18 for the first one. The second one, we're going to put, it's hard to see, so I'm going to use blue for this and see. This one will be 5, doesn't help enormously. The smallest one here will be 4, and this one will be 6. So 15, 12, 18, and 5, 4, 6. Or if I went by number order, it would be what, 12, 15, 18, and 4, 5, 6. But very particular which ones. So what we do now is, this is a way of proving that they are similar triangles if all 3 sides are in proportion, in the same proportion. So what we're going to do is we're going to match up sides. So up here, I'm going to write AB over, the matching one to AB is DE. And the amount of AB is 15, and the amount of DE is 5. That gives me a 3 over 1, or a 3. Ratios are usually in fractions. If it's over 1, you don't have to write the 1, but I'm going to keep it there just because if it's a ratio, it's 3 to 1. So this was a good, appropriate place to leave it as a fraction. Usually I'd say round it to 3. But this is appropriate to say it's a 3 to 1 ratio. Okay? Now I'm going to do the same thing with the next one. BC over the equivalent one, or the matching one, is EF. BC is the amount of 12, and EF is the amount of 4. And it just so happens this is also 3 to 1. If the third one doesn't come out to 3 to 1, they're not similar. If it does come out to 3 to 1, then they are similar. And so the third one is AC. Sorry, I'm running out of a little room here, but I think I can fit it in there. DF. And that's 18 over 6, and it looks like this one was set up to be similar there. If this one had been 7 instead of 6, you might not have been able to tell from looking at these that they weren't in proportion. But if that was 18 over 7, it wouldn't be 3 over 1, and you say, nope, they're not similar. There's just enough difference in the side lengths that they're not similar. But in this case, they all come to the same proportion. So because they all have the same proportion, we can say triangle ABC is similar to triangle DEF by side, side, side. So I made sure I kept the A with the D, the B with the E, the C with the F. The next one I might change which order just to show you can. And I have to say by SSS. And this stuff proves that it's SSS. So on the test, when I give you something like this, I don't know which one. Of course, you'll have one. I'm not spending the time here for no good reason. But make sure that if you say it's SSS, that you show the proportions. Make sure if you say AA, that you show, based on the information, that you show the 2 angles are congruent. Yes?
Does it matter that the ABC is on top of the DEF, or could the DEF be on top?
That's a good question, because you're right, it doesn't matter. It doesn't matter at all. If I had chosen to do DE over AB, I would have had a 1 over 3 result. I'd have to make sure the other ones I did did the same thing, where the smaller one was on top. As long as I'm consistent, I'll get the same ratio. I would get a 1 to 3 ratio each time, but they would all be the same, so it would be perfectly fine to do that. And notice I went this one to that one, that one. You could have chosen to do this one first and that one's third, or whatever. The order doesn't matter as long as it's consistent. So yes, it would have been perfectly fine. So an alternate answer for the proportions could have been 1 to 3 each time. You still would have said this the same. So yes, perfectly fine to that. In fact, sometimes you have enough information to do side, side, side with proportions, or to do AA like this, and it doesn't matter which one. If there are 2 possible answers, and on a test I see that some people did this, but they did this to prove it, and some people did this, and they did this to prove it, they'd both be right. But you have to make sure you have enough information. You have to watch carefully, because I probably will give you enough information for one. Accidentally there might be for a second, but there might not be. So just make sure that you have enough proof here doing this or that. Or the third one. And the third one has a little trick in it too. The third one, we sort of combine parts of these. So side angle side means that one side, let's give this information. I'm going to say 7.5 here. Let's put the info in here first. 3 and 2. Okay. In this case, I think I'm going to do what you were saying, and I'm going to show it with the smaller one on top, just because. Why not? Yes, AJ.
Is the angles
congruent?
Oh, yes, it is. See, right now, if I left it like this, I'd see that these are probably in proportion, and I'd figure them out, but there's not a third one, so I can't use SSS. I have this angle with one arc, but there isn't one on here, so there's not enough information for anything right now. So I better remember to do that so that we have, we can actually follow this. So, there are three little rules for this one. You have to be in order. Side, angle, side means going a side to an angle and then to the next side. So the angles that are the same have to be the angle in between the sides. So if instead of putting these arcs here, I put them for A and D, then I'd have like angle, side, side, and that doesn't work for similarity. It does work for congruency. If anyone remembers back in middle school math, one of the proofs of congruency is you could do a angle, side, side proof. But you can't do that for similarity, only for congruency. So stick to these three. Don't try to make one up. Okay? Sometimes they get interesting results on tests where people come up with a proof that doesn't exist. Very creative, but I'm afraid it's not working. So in this case, we have a side and angle aside, a side and angle aside. The angles are congruent because the single arc tells you that. That's a given. What we need to do is find out if the sides are in proportion. If they're in proportion, and we have this order of SAS, SAS, then it looks like we'd be good. So let's do DE over AB. And the amount of DE is 3, and the amount of AB is 7.5. Well, when you're dealing with a decimal like that, it's really helpful to use a calculator and get, what that simplifies to in order to compare it to the other one. So 3 divided by 7.5 is 0.4. If the other ones comes to 0.4, then we're in good shape. So that's going to be EF over BC. EF is 2, BC is 5. 2 over 5 is 4 over 10, which is 0.4. 0.4. And because we have to have the angle there, we have to at least say that angle B or angle E, whichever one, is congruent to the other one. So you actually need to say that as part of the proof. I could have written that in between, but I don't have to necessarily. I just have to show all three things. And now I can say that angle, let's do BCA, is similar to triangle. Well, I did this on purpose. I didn't do ABC this time. I did BCA. But if I'm going to do BCA, I have to match those up here, so I have to do EFD for the other one. By side, angle, side. So those are the three types of proofs for similar triangles. Not really that hard to do. There's not hard calculations. It's just a matter of remembering which ones and getting the order right. So this is more a matter of just knowing I'm particular about a couple of things and remembering the differences between them. So like a lot of things in math, it's not necessarily a calculation difficulty. It's just remembering and making sure you know that process. So let's look at the second page. So now we're going to use a mixture of things with the fact, two parts to it. We're going to prove that a couple of triangles here are similar, and we're going to solve down here for the variable x. Okay? So we have a triangle here for U, T, Q. And then we have QRS, or I guess it would be SRQ to match UTQ. We have two triangles. So what we want to think about is a proof that these two are actually, these two triangles are similar. Well, I noticed that some of the side parts are filled in here. And I could do like 8 over 12 as a proportion and get a 3 over, let's see, that's a 4, 4 goes in that twice and 3, that's a 2 over 3. So that's 2 over 3. But I don't know what x is, so I can't use the proportion here, because x plus 3 over 3x minus 1 might be 2 over 3, but it might not be. And until you know x, you don't know that. So I'm not going to be able to use any of the side bits, side, 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 or side, angle, side, because I don't have enough information because those are variables. So let's think about AA. Okay, the angle one would be the only thing left, and I know one thing right off the bat. When you have an intersection, remember about vertical angles from the stuff you did before. Automatically, this angle here, T to Q to U, TQU, is congruent to RQS, because they're vertical angles. So we know right now that angle TQU is congruent to angle RSQ. I'm matching up the ones that are the same on here, because if this one were flipped around to here, or not flipped, or translated around there, the R would match the T and the S would match the U. Okay. So I know that, but there's no information here, there's no arcs for the other ones. What there is that. What we have is two parallel lines. So one of the things that you did back in chapter 11 was that if you have parallel lines and you know that they're parallel, that tells you some information about the angles. So this gets sort of confusing here with these, so what I'm going to do is let's ignore part of it, and I'm just going to draw something up here. If this line and this line were here and here, and I use just this transversal coming through it, well, I know that this one and this one, these two are parallel, because it tells us the RS is parallel to UT. And you saw that on all your problems in section 11.2 and 11.5, the ones last month. Well, you know that if these are parallel, then you know that these two angles are corresponding and they're equal. These are interior, consecutive interior, and they add up to 180. And you also know something like this angle here are alternate interior angles, and they're equal. Well, if this transversal was this transversal, that means that this angle here and this angle here are alternate interior angles. So I'll put a double one up here to match that, since we already had a single arc used. So if these two are parallel, then these two angles are definitely congruent because of the alternate interior theorem. So I can now say that angle UTQ is congruent to angle SRQ. Now, since I'm not doing a full triangle similarity, I don't have to write here bivertical and bi-alternate interior. But now I'm going to use that for this, because now, because of this fact, because it's a transversal going through two parallel lines, now I have two angles. I have this angle matching that one and this angle matching that one. I have an AA. So now we can say triangle, and I guess it doesn't matter which order, but U matches S, so I'll start with that. U, or yep, it does. So UQT is similar to triangle SQR by AA. So, we've proven that these two are similar. Now that we've proven that they're similar, all the other things fall into place. Automatically, it means that this angle matches that angle. Automatically, it means the sides are proportional. So, I couldn't before use 8 over 12 matching x plus 3 over 3x minus 1, but now I can. Because I've proven that these are similar, now I can say that one side, that this side RS matches UT, or TU if I keep it in order there. And if those are proportion, and the other ones are in the same proportion, like the 1 over 3 equals 1 over 3, then all I have to do is make them equal to each other. But I have to keep the same consistency here. So let's set this up. So what I just did here is I took the side from the smaller triangle. It's in proportion to the side of the larger triangle, the matching side. If this is the smaller and that's the larger, this must be the smaller and that must be the larger. Now, all you have was a simple normal solve for x fraction. You've done this before. First thing you should do, of course, is simplify those, because if I divide them both by 4, I'm going to get 2 over 3 equals x plus 3 and 3x minus 1. Cross multiply 2, 3x minus 1 equals 3x plus 3. So I just cross multiply these. Let's make sure I got them right. Okay. 6x minus 2, 6 and 2, okay, and 3x plus 9, bring it up here, 6x minus 2 equals 3x plus 9, I'm running out of space here, and then I guess I'll add the 2 to both sides, so I get plus 11, subtract the 3x from both sides, 3x equals 11, and divide by the 3, 11 over 3. It's not a very clean number because it's, it'd be nice if it was like a 4 or a negative 2 or something like that, but fractions are possible answers. So 11 over 3 works. This is not a slope, so it's okay to say, let's see, that would be 3 2/3. So making a mixed number is acceptable. Okay. But some people like to make these a decimal. I don't want you to make it a decimal. If you make it a decimal, you have to say approximately 3.67 or 3.7. But I prefer you not do that. Okay? If you have to round it, I prefer you just leave it as an exact answer like that. If this had been 12 over 3, then it would have been 4, and you wouldn't have done that. That would have been appropriate. But if you're going to have to round a number, I prefer you not do it. So don't do it. If you do this and you use the approximation sign, I'll let you get away with it because it is okay to know that, but I just prefer that you not to. So I'll accept that. We'll go do a little, I shouldn't have done that. And I'll still give you credit. If you do this or this, you're good for it. Okay. All right. That's if you get one like that. All right. Any questions about doing these things? Okay. So let's do a quick review of that. You have to make sure you know those things, all 3 of them, and how to show that it's true by doing that, or doing that. Making sure you get these things exactly right, the way I want them, with the little order of the things and the by whatever. And over here, if you get a figure like this, remember that because I tell you a couple of lines of parallel, that opens up possibilities for you to match up some of the angles and say that they're congruent. Don't forget about that, because that's where probably the most difficulty people have with these problems tends to be they forget they can do that and figure out that, oh, these two are going to be equal. Okay, and then that solving part's not hard to do. Okay, so that's section 14.1.